Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate what is called percent error. And before we start calculating percent error, we should probably start talking about error in measurement in general. It says right here that anytime measurements are made with a measuring device, that measurement is going to be approximate. And it says right here that if you measure the same object two different times, the two measurements may not be exactly the same, and the difference between those two measurements is called an error in measurement. So what this is saying is that anytime we take a measurement of something using a measuring device, there's going to be a certain degree of error in our measurement. Why is that? Well, that is because the instrument that we might be using might not be calibrated correctly, or there might be some human error involved in the taking of our measurement. But just understand that anytime we take measurement of something using a measuring device, that measurement is going to be approximate. It is not going to be the exact value. There's a certain level of error in those measurements. And so how do we calculate error? Well, it says right here that to get the error, we simply take the measured value minus the actual value, and this will give us our error. So if we take a look at these three different examples down here, we have some objects that have been measured. We have mass here, we have length here, and we have volume here. And so if we take a look at these coins here, the measured value by a group of students in a lab, let's say, of these coins was 25.69 grams. However, the actual value of the mass of these coins is 24.75 grams. So how do we get the error in the measurement here? Well, to get our error, we're simply going to take the measured value, which is 25.69 grams, and we're going to subtract the actual value, which is 24.75 grams, and we're going to end up with an error of 0.94 grams. And typically when we're measuring error, we're going to use either a positive sign or a negative sign. So right here, our error is a positive 0.94 grams. This means when we took this measurement, we ended up with 0.94 grams more than what we should have gotten. Our error is positive 0.94. Let's take a look at this example right here. When a student in the lab measured the length of this pencil, he measured the length of this pencil to be 23.65 centimeters. However, the actual length of this pencil is 24.30 centimeters. So how do we get the error in the measurement here? How do we get the student's error? Once again, to get the error here, we're going to take the measured value, which is 23.65 centimeters, minus the actual value, which is 24.30 centimeters. And when we put this in our calculator, we're going to end up with negative 0.65 centimeters. So it looks like our answer here, or our measured value, is approximately 0.65 centimeters less than what it should have been. Let's take a look right here. If we take a look, when we measured, or when a student measured the water that is in this graduated cylinder, she measured the value of the water to be 9.30 milliliters. However, the actual value of the water that is in this graduated cylinder is 9.40 milliliters. How do we calculate the student's error? Once again, to get the error in our measurement here, we take the measured value, which is 9.30 milliliters, minus the actual value, which is 9.40 milliliters, and we're going to end up with negative 0.10 milliliters. So the error in this student's measurement is negative 0.10 milliliters. So now that we know how to determine the error in measurement, what we can now do is calculate the percent error in measurement. So let's go ahead and do that next. So what is percent error, and how do we calculate it? Well, it says right here that percent error compares how close your measurement is to what the measurement's value actually is, and we're going to express this as a percentage. So to get the percent error in your measurement, we simply take the absolute value of our error, which we learned how to calculate in the previous slide, and we divide that by the actual value and multiply by 100%. So to get the percent error, we take the measured value minus the actual value, and we're going to take the absolute value of that. We're going to divide that by the actual value and multiply by 100%. So if we wanted to figure out the percent error in the measurement here, how do we get that? Well, to get the percent error, we're going to take the absolute value of our measured value, which was 25.69 grams, minus 24.75 grams, which was our actual value. We're going to take the absolute value of that, and we're going to divide that by our actual value, which was 24.75 grams. Last but not least, we're going to multiply this by 100%. And if we put this all in our calculator, if we take 25.69 minus 24.75, and we take the absolute value of that, then divide that by 24.75, and multiply by 100%, we should end up with approximately a percent error of 3.80 or 3.8% error. So this measurement right here is 3.8% more than what the actual measurement is, or the actual mass is. Let's take a look at this example right here. To get the percent error in these two measurements right here, we take the measured value, the absolute value of the measured value, which is 23.65 centimeters, minus the actual value, which is 24.30 centimeters, and we're going to divide this by the actual value, which is 24.30 centimeters, and then we're going to multiply by 100%. And so when we put this in our calculator, when we take the absolute value of 23.65 minus 24.3, and then divide that by 24.30, and then multiply that by 100%, we will end up with 2.67, or approximately 2.7, a percent error of about 2.7%. So what does this answer mean? Well, if we take a look, our percent error here is going to be 2.7%. So that means that our measured value is 2.7% off of what the actual value is. We have a little bit less here. Our measured value of this pencil is a little less than what it should be, 24.30. Well, how much less? About 2.7% less than what it should be. Let's take a look at this example right here. If we wanted to calculate the percent error of these two measurements right here, we're going to take the absolute value of our measured value, which was 9.30 milliliters, minus the actual value, which was 9.40 milliliters. We're going to divide this by the actual value, which was 9.40 milliliters, and multiply by 100%. And so when we put this all in our calculator, we take the absolute value of 9.3 minus 9.4, or 9.30 minus 9.40. We're going to divide this by 9.40, and then we're going to multiply by 100%, and it looks like we end up with 1.1 approximately. 1.1% error here. So our measured value is about 1.1% off of what the actual value is. We're a little less than what the actual value was. So that's how we're going to calculate percent error. Let's take a look at a couple more examples. In this example right here, it says a student in the lab measures the density of water to be 1.15 grams per milliliter. If water has a density of 1.0 grams per milliliter, then determine the student's percent error. So in the lab, a student figured out that the density of water was 1.15 grams per milliliter. However, we know that the density of water is in fact 1.0 grams per milliliter. We have to figure out the student's percent error. So to get the percent error, here's our little formula. So let's go ahead and apply this. Let's see here. It looks like the measured value the measured value or the measured density by the student in this lab here was 1.15 grams per milliliter. And if we take a look, the actual density of water happens to be 1.0 grams per milliliter. So we have to figure out the percent error. So to get our percent error here, we simply take the absolute value of our measured value, which is 1.15 grams per milliliter, minus our actual value, which is 1.0 grams per milliliter. So we're going to take the absolute value, and then we're going to divide that by the actual value, which is 1.0 grams per milliliter, and then we're going to multiply by 100%. And so when we put this all in our calculator, when we take the absolute value of 1.15 minus 1.0, and we divide that by 1.0, and then multiply by 100%, we get 15%. So 15% error. That means that the student in the lab, their density value here, what they measured it to be, was 15% off of what it actually is. Let's take a look at another example. In this second example, it says a group of students were asked to measure the circumference of a giant redwood tree. The students took the measurement 4 different times. Their results are in the table below. If the circumference of the tree was 14.12 meters, then determine the group's percent error. So it looks like we have a group of students, and what they've done is they've measured the circumference of this tree right here. The circumference is the distance around the trunk of this tree, right? It's the distance that goes around the trunk of this tree. And so it looks like the students performed 4 different trials. In the first trial, they measured the circumference to be 13.63 meters. In the second trial, they measured it to be 13.95 meters. In the third trial, 13.26 meters. And in our fourth trial, it looks like they measured it to be 14.15 meters. We know, it says right here, that the actual circumference of the trunk of this tree is 14.12 meters. We need to figure out the group's percent error. So what we have to do is we have to first figure out the measured value. We have 4 different trials here. So how do we get the measured value from 4 different trials? Well, we're going to take an average. We're going to take an average of trial 1, trial 2, trial 3, and trial 4. So let's go ahead and get their measured value. To get their measured value, we're simply going to take an average. We're going to take an average of all 4 trials, so 13.63 meters plus 13.95 meters plus 13.26 meters plus 14.15 meters. And because there are 4 separate trials here, we will divide all of this by 4. And so when we put this in our calculator, we take 13.63 plus 13.95 plus 13.26 plus 14.15, and we're going to divide this by 4. We end up with 13.75 meters. So here is our average measured value for these 4 trials. And so now to get our percent error, what we're going to end up doing is we're going to end up taking our measured value, which is 13.75, that's our average, minus our actual value, which is 14.12. We will then divide it by the actual value and multiply by 100%. So let's go ahead and do that. Let's see the absolute value of our measured value, which is 13.75, minus our actual value, which is 14.12 meters. We're going to divide this by our actual value, which is 14.12 meters, and then we're going to multiply by 100%. So let's do this. We take 13.75, the absolute value, minus 14.12. We're going to divide this by 14.12, and then we're going to multiply by 100%, and we end up with 2.6. or 2.62. Percent air. So it looks like when these students measured the circumference of this tree here, they were about 2.62% away. Their measurement right here was about 2.62% away from what the actual measurement was. And if you take a look, they were actually pretty close. 13.75 meters is what they measured it to be. The tree's actual circumference was 14.12 meters. All right, so that is percent air in a nutshell, and that is how we calculate percent air. And I hope you guys found this helpful.